How are you guys? This is lecture 2, covering fractions and least common denominators in my algebra course series. Please, to see the other lectures, check the playlist called Algebra Course Lectures. Let's start lecture 2. We start with the properties of real numbers. There are some properties I will mention here. One property is called commutative properties. Commutative properties say that if we have two numbers are added or multiplied in any order, they give the same result. So if we have a plus b, this is the same as b plus a. So this is in the addition. A times b is equal b times a. Simple examples here I mentioned, 4 plus 9 is the same as 9 plus 4. 3 times 8 is the same as 8 times 3. So this property, commutative property, the verb here is commute. So it does not apply for subtraction or division. It applies only for multiplication and addition. Another property is called associative property. If we have three numbers, a plus b, added together in a bracket, plus c, is the same as if we add b plus c in a bracket, then it is added to a. So in the addition, we have correct statement. Also in the multiplication, we have a times b in the bracket times c is the same as a times b times c in the bracket. So we call this associative property. So if we have 7 plus in the bracket 18 plus x, to find the answer, this is the same as adding 7 and 18 plus the x. So we can add the numbers together like terms. So the answer here should be 25 plus x. Remember, this is an expression also. We cannot find the value of x. So this is only an expression. Third property we can see here is distributive property. The verb here is distribute. Distributive property or distribution property, we can say also. The property states that a times, in the bracket, b times c, you can see that here, it will be a times b plus a times c. You can distribute a over the sum. The same property we can use for subtraction. So if we have a times b minus c in the bracket, it will be a times b minus a times c. We can do that. Also, we can extend this property to have more than one number in addition or subtraction. So if we have a times b plus c minus d plus e, we can distribute the a times b plus a times c minus a times d plus a times e. That will be the same number. Now let's explain the word reciprocal, please. Very important word you can use in math. Two numbers whose product is 1 are called reciprocal of each other. So 5 over 4, if I need to find the reciprocal, so I ask myself, what is the number I multiply with 5 over 4 to give me 1? So the answer will be 4 over 5. So to find the reciprocal, you should multiply the number with the reciprocal, and the answer should be 1. Now remember, if we have 0 over b, just a remark there, important note at the end, 0 over b, that's 0, if b is not 0. b over 0 is undefined, that's not a real number. So 5 over 0, 7 over 0, 6 over 0, this is not a real number. Now let's look at this example 5. identify the property given in each statement. 5 over 8 in the bracket 16y. If I write 5 over 8 times 16 in the bracket times y, what do we call this property? You can pause a little here and check the properties that we explained at the beginning. 15x minus 10x squared. I can write 5x in the bracket, 3 minus 2x. And then 2x in the bracket, 3 plus y. 3 plus y times 2x. Just a simple note here that this lecture 2 comes after lecture 1 in the series of the math algebra course. We can see here, the first one is associative property, because you can take 5 over 8 as A, 16 as B, Y as C. In the second one, we see distributive property. If you take common factor 5x outside times bracket 3 minus 2x, so this is a distributive property. And the last one is commutative property. 2x like A, 3 plus y like B. So A times B is equal B times A. So this is commutative property in multiplication. Now, here we have some properties that you might need in algebra. Remember, this is a basic algebra course. Just I'm mentioning the property with an example. Some math users or some students, they are a little weak in math, so they are confused sometimes with the sign, S-I-G-N. So listen carefully, please, for the property here. So I listed in this slide 6 properties and simple example on the right side. Now, if you have minus 1 in the bracket times the A, that means minus A. Now, A here can be positive or A can be negative, remember. So minus 1 times the A becomes minus A, like this one here. Minus 1 times 5 is minus 5. Minus, second one here now, second property, minus minus A. If you have 2 minuses, you multiply 2 minuses, it becomes plus. So the answer is A, whatever the A is. Minus A in the third one, please. Minus A in the bracket, you see the third one here, minus A in the bracket times B, the same as A times minus B. Same as minus AB. And if you know the numbers A and B, you can multiply them, like in the example here, 5 times 7, 35. Or you can leave it if you don't know A and B or X, Y, leave it. Number 4, minus A times minus B. So you can multiply the minuses together, and then what you are left with AB only, so you write AB or A times B or BA. Now, number 5, if you have minus in the bracket, A plus B. So this is like distribution property, number 5, minus A minus B. That's easy. Number 5 is easy. But look at number 6. Little tricky. You have a minus times the A minus A. We know that, see? Minus minus B. Minus minus B. So it will be plus B. So we have B minus A. You see the answer here, little tricky in number 6, please. Please take care of number 6. More properties, but on fractions here. Property number 1 on the fractions. A times C divided by B times C. You can cancel the C, and then the answer is A over B. That's a simple example on the right side. If we have 2 times 5 divided by 3 times 5. Cancel the 5, the answer 2 over 3. Now B, number 2. A over B times C over D. This is multiplication of fractions. Multiplication of fractions. So you multiply the numerators, A times the C, divided by B times the D. Like that one on the right side. Then you can simplify if you can simplify. Number 3, division of two fractions. Please be careful about number 3. A over B divided by C over D. I change division into multiplication, and then I multiply by the reciprocal. You see, C over D, the reciprocal becomes D over C. So I multiply AD divided by BC. That's an example on the right side. Number 4, if there is two fractions equal, remember here, we should have equal between the two fractions. A over B equals C over D. One fraction is equal another fraction. So that's AD equals BC. We call it cross multiplication. So this is a cross multiplication. Okay. Now, A over C plus B over C. Oh, this is addition. If you add fractions with the same denominator, you add only the numerator. I will say that again. If you add fractions or subtract, number 5 and number 6, if you add fractions or subtract fractions with the same denominator, then you add the numerator or you subtract the numerator. That's easy. See an example on the right side here, 4 over 5 plus 7 over 5. The same 5, you see that? So 4 plus 7 is 11. 4 over 5 minus 7 over 5. The same 5 is there. So 4 minus 7 minus 3 over 5. Now the problem comes for many math users or many students if the denominators are different. That's a little tricky part in mathematics. If the denominators, I wrote here, if the denominators are different, just be careful. Listen, please, how we add or subtract fractions. So you have to know the word LCD, very important. LCD means the least common denominator. Least common denominator, LCD. How do you find LCD? You have to find LCD first. If you have addition or subtraction of two fractions with different denominators, you have to know one do you need to find LCD. Now, how to find it? Okay, just 2 lines. I will read it and give you so many examples. LCD is the product. So you have to multiply numbers, things together. It's a product of each different prime factor. Product of each different prime factor, each raised to its highest power. Now read it 1 time, 2 times, 3 times, and listen carefully for the examples to understand it. Now you can check in other videos what is the definition of prime numbers or prime factors. Prime numbers is a number that can be divisible by itself and 1 only. Now let's look at this example. We have 3 parts in this example. Suppose you have the first fraction here, 7 over 3 plus 5 over 2. Just listen for the first one here. This one, 7 over 3 plus 5 over 2. The first thing you have to notice, the denominators are 3 and 2. So you cannot add directly. You cannot add directly. Now, each denominator here is prime number. See, 3 is prime number. 2 is prime number. So just multiply 2 and 3. So this is the LCD. This is the least common. But not always we multiply 2 and 3 or whatever the numbers are. Not always. I will give you the second example to explain. Second example here in this slide. Now, 7 over 3, I have to make This 3 and 2, 6 and 6. How can I make the 3 here 6? I should multiply by 2. I should multiply also up by 2, up and down by 2. So 7 over 3 becomes, on the right side here, 14 over 6. 5 over 2, I have to multiply by 3 up and down. So it becomes 15 over 6. Now look at the fraction, the blue and the red. This is 3 and 2, we cannot add. Now we have here 6 and 6 in the denominators. We can add. We can add here. But see, we add now 14 and 15, 29 over 6. We cannot add here directly 5 and 7. Now that's easy. Look at the second one, please. That's the second example here. 3 and 9. See the denominators, 3 and 9. We cannot multiply 3 and 9 because 3 and 9 becomes 27, right? 3 and 9 is not the LCD. It is not the LCD. Now here the LCD is 9 because 3, you see 3 power 1 and 9, 3 squared. So this is the same prime number, 3 power 1, 3 power 2. Just listen carefully, please. 3 power 1, 3 power 2. Same prime number. So we take the highest power, which is 3 squared. We don't multiply always. So now we have to change the first one, 7 over 3, change it to 9. So I multiply by 3 and 3 becomes 21 over 9. We leave the second one, it's already 9. So 21 minus 5, 16 over 9 is the answer for second one. See how nice it is to find the LCD? These are the simplest examples. You can continue with other examples. And sometimes later, maybe lecture 5, 6, or 7, we will have fractions where we have variables like 1 over x plus 1 over y, a over b minus b over a, something like that. You can wait until that lecture. Now let's see the third example here. 2 over 15, last one here, last line, 2 over 15 plus 5 over 9. I cannot multiply 15 times 9. This is not the LCD. No, we cannot multiply. Now, 15 is what? What is 15? If you make it prime numbers, 3 times 5. Just keep it on a piece of paper. So you can write 3 times 5. Now 9 is 3 squared. So I have to take each prime number raised to highest power. So 3 power 1, 3 power 2, I take 3 power 2. 5 power 1, only 1 5, so I take 5. So 5 and 3 squared becomes 45. So if someone asks you what is the LCD for these two fractions, the answer should be 45. Now, how do you make 15 here? Make it 45, multiply by 3 up and down. And the 9 multiply by 5 up and down. So we have the same denominator, 45. Then we can add 6 plus 25, 31 over 45. Let's see more, I think, more and more examples. I advise you here, please, you can pause the video for a minute or so and try A, 3 over 8 plus 7 over 10 minus 1. And then you try after that 5 over 36 plus 7 over 120. You see, all the denominators here are different. So the first thing you have to do, find the LCD, least common denominator. And I will explain again and again, to find the LCD, you have to factor each denominator. Don't look at the numerators. Each denominator, make it prime numbers. Then choose the prime number with the highest power. After that, you multiply all these numbers. This is the LCD. Okay, let's see the first one, please. 8. Let's look at 8. What is 8? Prime numbers, it's 2 times 2 times 2. So we can write 2 cubed. See, very simple here. 8 is 2 cubed. 10, how about 10? 10, to make it prime numbers, break it down into 2 times 5. Now I have to compare the prime numbers. 2 power 3, 2 power 1. It's very clear the highest power is 2 power 3. So I take only the highest power, 2 power 3. And then there is no number except 1, 5. So I take the 5 times 2 cubed. So the LCD is 40. So maybe somebody will ask you in this question, find the LCD only. So the answer will be 40, 40. Now, look at what I did here very clearly. Change all given denominators to 40. See, you don't see 40 in the question. We have 3 over 8, 7 over 10, minus 1. Minus 1 means minus 1 over 1. So there is no 40. So I have to make each denominator 40. I put here in details how to do it. 3 over 8, you see this is the question, 3 over 8. The important part, I have to make the denominator 40. So I multiply 8 times 5. I cannot do that unless I multiply 3 times the 5, up and down, see? So that will be 15, 15 over 40. Now, 7 over 10. To make 10 40, I have to multiply by 4. I have to multiply also numerator, denominator by 4. So 28 over 40. There is a minus 1. See, minus 1 over 1. So I multiply by 40 up and down. So the whole question now becomes very nice. 15, you see here, the answer here, 15 plus 28 minus 40. See, when you add, you get 3 over 40. That's the answer. Now, I hope you have tried the second part here, B, 5 over 36 plus 7 over 120. If you want to try, you can pause the video for a minute or so, and then I will show you the answer. B part is like this. 5 over 36. So I take 36 and break it down. See, the 36 is what? Whatever you do in the 36, you have to reach 2 squared times 3 squared, which is 4 times 9. Because you need prime numbers. You cannot leave 4, you cannot leave 6, you cannot leave 12. See, whatever you do, you have to reach 2 squared times 3 squared. Leave it. Now let's go to 120. I can start, see, I put the 120 in details for you here. See, the 120, I can write 12 times 10. We know that easy, 12 times 10. Now the 12 is 4 times 3, 10 is 2 times 5. So I look for the same prime number, 2, 4, 2, 4 becomes 2 cubed. 2 cubed, because 4 is 2 squared, and there is 1, 2, so 2 cubed times 3 times 5. Now I compare 2 squared, 2 cubed. What is the highest power? 2 cubed. 3 squared and 3. What is the highest power? 3 squared. Times the 5. So when you multiply, you get 360. You have to now change 5 over 36. You have to change it to 360. So multiply up and down by 10. To make 120, you have to make it 360. Multiply by 3 up and down. See, 5 times 10 is 50. 7 times 3, 21. So the answer, 71 over 360. This is the answer for the addition. Just, I'm here explaining what is a number line. Real line is, we call it number line. Number line is the number line where we present or represent all the real numbers. They can be positive numbers, they can be negative numbers, They can be zero, can be fractions, rational numbers, radicals, anything. If a number on the left, so we can write a less than b. So any number on the left, on the left of b, then we can write a less than b. Also, we can use inequality symbols like less than or equal, greater than or equal, to compare numbers. Like we can say 7.4. Look at the last line here. 7.4 greater than 7, less than 7.5. We can say minus pi less than minus 3. See, if you multiply here with minus, you have to change the sign. Remember, in algebra, there's another section you can see, minus pi, multiply with minus, so pi will be greater than 3. 2 is greater than square root of 2, because square root of 2 is 1.4. If we have the same number, we can use equal, or we can use 3 less than or equal to 3. Is that correct statement? All right. Now write each statement in terms of inequalities. Just a simple translation, since this is lecture 2. And later we can see more examples. Let's see at the first one. K is greater than or equal to 10. The second one, X is less than 0.5 and is greater than minus 7. So how do we do that? K is greater than or equal to 10. So K greater than or equal to 10. Just write the inequality by translating the whole English sentence. X is less than 0.5, so we say X is a number less than 0.5 and greater than minus 7, so you should write it this way here. The second example B. All right. Now this is try at home. If you have seen lecture 1, there is try at home 1, because this is continuation. So in this course, some lectures are connected together, like here 1, 2, 3, 4, they are connected. And then 5 and 6, they are same topic. So we go by each topic. Topic number 1, real numbers, it will take 4 lectures, short lectures. So in the first lecture, you found there's one nice question, try at home 1. You try it, the answer is there. Also here, perform the indicated operations. Try to find this answer, and then the answers on the next slide here. To see the detailed solution of these, you can check other videos on order of operations. Now we will continue this topic. This topic is to be continued in lecture 3. As I mentioned, lecture 1, lecture 2, lecture 3, lecture 4, they are the same topic. Then we move to another topic. Thank you very much for watching. I hope I can see you in another video with another topic. Thank you very much.